Okay, so let me see. Who wants to go first? You know what? I have William Gregory. Let me put him on first. I'll ask him to unmute. And, oh, you know what? Yeah, William, you there? He may not have his mic on. Well, William, okay, I'll mute him back up. So William was asking, he had a question about reaction wheels and satellites. Does the satellite always rotate around its center of gravity in space? And if you change the center of mass, will it change the rotation point?
I would say yes. Your center of mass, yeah, that's what it rotates about. Just like a ship on water, it doesn't turn from the bow, it turns from the center of gravity.
Okay. So let me go to Jeremy Rys next. He's got his hand up. So Jeremy, go for it, sir.
Yeah, we were curious, Mike, what was the primary finding of the research with that last device you showed? And
well, we could maintain station keeping. That's the whole object of the game, is these things drift around out there a little bit. Your parking orbit is plus or minus 3 feet at 22,000 miles. So your controller has to be pretty good.
Now, if I could jump in real quick, when you say station keeping, you've got orientation, right? You've got orientation to a fixed point on the Earth.
Correct.
But then you've also got, so you also have,
well, this thing's moving at 17,000 miles an hour, and as the wind blows, it starts changing orientation a little bit due to whatever, gravitational influences from other satellites, planets, or whatever. And it doesn't always stay there, so you have to have something. Some satellites have, rockets on them, propellant thrusters. And when the thrusters burn out or run out of gas, then the satellite's dead. So if you use gyroscopes, all you have to do is spin them up, and they're electrically powered. So, a solar cell, and you're in business.
Okay, so yeah, so when you mean station keeping, you're actually talking about pushing it further out, presumably out of the Earth's gravity well then, right?
Well, no, you're already out of the gravity well. You're sitting out at 23,000 miles, pointing at a particular point on Earth, and due to whatever's going on out there, this thing will want to twist around or point a little high or point a little low.
Okay. So you're talking about orientation, not movement.
Well, orientation, also back and forth. You want to keep it on this particular spot. And that's what the object of the propulsion system is to what they call station keeping.
Okay. Okay. Thank you. I should apologize for that. Let me go to Mark next. Mark?
Yes, you can hear me. I had a couple questions for Bill. On the first presentation, you talked about that Earth's field was getting compressed by about 1 to 2 Earth radiuses. Which direction was that happening in? Was it
forward direction?
The forward direction, meaning like the 3 a.m. side of Earth that's spinning around the sun?
The planet is going through space at a pretty good clip, and the leading edge of the magnetosphere is getting compressed by whatever it's hitting.
Okay.
I use the term aerodynamics because I'm an airplane engineer, but there ain't no air out there, so it's being compressed by something else.
What about the solar wind? Does that play?
Well, yeah, that's part of it.
That's okay. Another thing, you mentioned that the geosynchronous orbit seemed to be related to a frequency like 7.1.
Well, it's 1 hertz out, one wavelength out from the planet.
Right. How would that work with the planet Venus, which has like a rotation period of like 200 days or something like that? Does that equation still work on Venus?
It probably does, but the numbers will all be different.
Well, Venus is almost the same size as Earth, so.
Well, yeah, but there's these. Well, yeah, it's about the same size, but you're gonna one, that planet doesn't rotate, so it's a dead planet compared to this one, which rotates.
Okay. And how would that affect the frequency of the planet?
It would be a little bit different.
Mars rotates at the same speed as Earth and is a lot smaller. So would that work there as well?
Well, I'm sure it would hold for all of them, except all the rest of the planets by, well, my research, I would call them dead planets because they don't rotate like the Earth does.
Jupiter spins even faster, has a much more powerful magnetosphere. So how about that?
Yeah, well, you don't, yeah, you only see the outside, the in-between, you're seeing what you see in called Jupiter is just the outer shell of the magnetosphere, the covering, if you will.
Now, the magnetosphere of Jupiter is humongous. If you were to see the whole magnetosphere, it would be the size of the full moon. It's actually really, really large. Another question about the gyroscopes, which is something that I'm physically working on. You mentioned that the most important thing is really just the frequency of it moving back and forth, right? Is that correct?
Yeah. There's an optimum frequency of how many degrees you want it to rotate and the speed that you can rotate. Now, I just got done, as you know, I'm building this little demo model for Tom for the COF presentation.
Mm-hmm.
I just upgraded the servos we had some slow ones that couldn't quite turn it at their rated speed because there was too much mass there. So I had to put bigger servos in.
Oh, okay. Also, I noticed with my setup, we also had to upgrade our servos. Many of these servos can run at more than 5 volts. So if you up the voltage, you get faster, faster impulse. We're doing that using a buck converter here on the bottom.
Yeah.
Oh, okay.
Go ahead.
Well, actually, I was going to jump in and go to the next question because they're kind of piling up. Let me go to Wayne Ojala. Wayne was asking about these rumors about Boeing's anti-gravity program. Wayne, are you with us? He's here. He's just being quiet. Well, yeah.
I can put my 2 cents worth in. I'm probably the official anti-gravity Boeing person right there.
Okay, there you go. There you go. Yeah, I mean, rumors started circling. I remember this back 2002, 2005, around that era about Boeing playing with Beefield Brown, playing with all sorts of different technologies. But it's,
well, to me, the way to go is all you have to do is reverse the gravity field, and you don't even have to worry about the gravity well because you just float right out of it. That's the easy way.
Let me see. Let me go to David Alzafon. David, are you with us, sir? Okay, and he is here. I just have to find him. Oh, David is still muted. Okay, there we go.
Okay. My camera's on too, but I may not be visible for some reason.
Yeah, no, I can hear you and we can see you. Go ahead, David.
Okay, but what was the question you wanted, or was it my turn to ask?
Oh, it was your turn to ask. You mentioned something about your father. Your father worked at Boeing, right? So.
Yeah, absolutely. In fact, I always thought this paper that he wrote caused some rumors. See, Boeing Aerospace crossed out there. He was in optical research, but he wrote a paper on gravity control while he was there. But I was wondering, my question for Mike actually was, since he was doing optical sensor research for satellites, I wondered if you ever heard of his work, Mike, while you were there.
What was his name?
Frederick Alzafon, same last name as me.
No.
Okay.
No.
And Yeah, Mars, has no magnetosphere. How does that affect your theory about
Well, it wouldn't,
gravity?
because it's, in my book, it's a dead planet, so it wouldn't have a magnetosphere or much of one. Same as the moon's got nothing to protect it. That's why it's all pockmarked.
Yeah, because there's no molten core, right? Doesn't your model require a molten core?
Yeah, that's how you get the spin, because it works like electric motor.
Okay, so let me mute David there. Let me see. Yanis, did you have a question, sir?
Yes, yes. So my question was, because the Earth has different layers of these frequencies, right? If I understood correctly, could there be some like, if this is the planet and we make a wire around of it, or like a mesh of wires? I understand it's a huge project, but I don't know. In theory, perhaps, to harvest some type of energy, or maybe to have another frequency band besides the ones you described.
Well, if
I
you,
was
if you,
wondering.
if you resonated with any of the four that are supplied by the Earth, I'm sure you could borrow some of that power. It's got to be astronomical.
Yeah. Wow. Okay. And
I mean,
my other.
when you look at the numbers, you know, you got 10 to the 23rd, 10 to the 30th, and all those kind of numbers. I mean, it's huge.
Have there been any I mean, I can imagine the US has the resources for this type of things, but were there no were there no actions into this question?
Well, I'm of the opinion they already got machines built to do this. The black world, which nobody talks about.
Understand. Okay. And
I mean, half these so-called UFOs you see flying around here are probably manufactured in the USA.
yes, I understand that. Yeah. And I read David Alsophan's questions as well, and he asked, how did Tesla measure the electromagnetic field as he described? And I was very curious about that question too, if you can answer.
I don't know exactly how he did it. However, it is documented in his Colorado experiments that he did measure it, and his numbers are accurate to about at least 2 digits, if not 3.
Mm-hmm. And do you have input on this number games he played in his mind, like 369, and he had a lot of this almost I will say psychotic, but almost like very deep question, pyramid stuff. Number 3 played a huge importance. Do you have any inputs on that?
Well, I've read a lot of his books. It's hard to get books written by Tesla.
Yes.
There's more books by people about Tesla, but to dig into his research, the best spot that I found is the Tesla Museum over in, I think, was it Belgrade over there?
His hometown, yes.
Yeah. I know a guy from that neighborhood. I met him at the conference. But if you look at his research for the Colorado experiment, he was well aware of the quarter wave inner belt and the half wave outer belt. And his electromagnetic spectrum numbers are just too close not to be connected to the same gravity numbers. They're just too close. When you see numbers that close in the data, there's got to be a connection.
Okay. Are there any, from what you read, are there any information which the community at the time disregarded or thought insane, but he was like about this?
Yeah, he never commented on gravity, but I am of the opinion that he knew quite a bit about it.
Mm-hmm.
Because in researching his numbers, they're too close not to be. I mean, if you've seen two numbers that are almost identical, there's got to be a connection. So I think he knew a lot more about gravity than what he was.
Wonderful. Okay, well, Yanis, thank you again. And let me see, let me go down. So William Gregory, let me see, William Gregory, do you want to try and unmute now, sir? There we go. But we still can't hear you. Okay, I'm gonna mute him back up. Then it looks like his mic is still having problems. Let me see, who wants to go next?
Hello, can you hear me now?
Oh yeah, now I can hear you.
Oh, okay, great. I got too many mics here, analog and digital. My question is on. I'm real interested in reaction wheels. I'm experimenting with ideas on liquid reaction wheels, and there's a reason for that. But I was wondering if our speaker had any information on some of the liquid metal reaction wheels that have been patented. I've seen a few patents on them. And if you have any information regarding that, MHD type.
Oh, okay. Mike, you're still muted, sir. There we go.
Oh, okay. So I got muted. Okay. The reaction wheels, we used them for dampening when they were placed wherever there was large vibrations. So when the structure started shaking, you turn these reaction wheels on to dampen out the vibrations. They're not as well controlled as a CMG gyro, but that's the only experience I have with them.
Okay, so you don't have information regarding liquid reaction wheels, because there's a number of new patents out on liquid reaction wheels, and whoops. Okay, I got to sign off, man. I'll send you a text. Thanks.
Okay, and let me see. Thank you, William. Sorry, it's a little chaotic. Let me go to Jerimiah next.
Yeah, just to mention William, I don't know if he can still hear us, but it'd be really awesome to get some of those patent numbers from you about those liquid reaction wheels. We've also been very interested in that, especially for the liquid metals research, including gallium and perhaps mercury under safe conditions. So then my question for Mike was, in your work with Boeing, did you guys ever test actual lift force generated or generate any kind of numbers for like newtons of force on average over time?
Yeah.
And how large were those numbers?
A couple 100 pounds.
Wow.
The test article itself weighed 1,500 pounds. We lifted it with a 2-ton crane. Those big gyros were about 300-400 pounds apiece. And then the setup, the test article would generate about 200-300 pounds of thrust or torque, whatever way you want it. Depends on how you spin the gyros, whether you get torque or thrust. If you spin the gyros the same way, you get thrust. If you spin the gyros opposite way, you get torque.
Yeah, that makes sense. That's kind of crazy. Wow. Very, very interesting. So is that all just because the relative speed of the gyro at any given point in comparison to the surface of the Earth?
No, it's a function of 3 points or 3 parts. The mass of the rotor, the speed of the rotor, and the speed of torquing. Those 3 determine the output.
Right, but I mean, compared to the Earth frame of reference, right? Because this device can generate a force that basically allows it to float away from the gravitational field of the Earth, right?
Yeah, it's inertial. The problem with gyros, you can't blast off with them, because until you get it in space and you zero out the weight of the frame, okay, you got 1,500 pounds and it generates, say, 300 pounds of thrust. Well, you're not going to get off the Earth's surface at that. But once you get the 1,500 pound frame out into space, that 1,500 pounds goes away. So all you have is a generator that generates 300 pounds of thrust.
Yeah, awesome. So in space drives, exactly. That's totally awesome.
Yeah,
That's a lot of force, dude. That's a lot of force.
Yeah, if I was going to jump in, I would say that sounds like that's kind of a demonstration of inertial propulsion then. And
Well, that's what it is. That's exactly what it is inertial propulsion. Now they have 4 big gyros on the space station up there here a couple of years ago. One of them died and they had to put a new one in place. That made the news.
Yeah, well, it sounds like that's proof positive for inertial propulsion. That's why I mention it, because one of the criticisms that I've always heard is if you have one axis constrained, you know, there are all these little terms and conditions that always get applied to inertial propulsion, right? But the I guess the ultimate test of it was in space, and you're saying that works and it's already been used.
Well, they've been designed in the 60s, and every satellite, including all the little ones that, well, Hughes sends up a lot of them, Martin Marietta, and well, Boeing used to, but they don't do satellite work anymore, which is why the lab was shut down. But no, they've been used out there since late 60s.
Now, Eric Brandenburg had a question. Eric, do you think, can I ask you to unmute? Could you start your camera, sir, or do you want me to ask for you?
Can you hear me?
Yeah.
Yeah, I mean, it was just, I guess the question, and I've seen other people post as well. So what we're saying is this actually produces thrust?
Yes.
And if so, why isn't it, I mean, you're implying that it's actually placed on satellites and it's used for that purpose. I would think we would have heard more of that. And also its use for, you know, interplanetary travel.
Well,
if you can get a constant acceleration off of it.
If you Google NASA and they have pictures of the 4 gyros sitting on the space station.
I just thought those were really just used for orientation rather than, you know, as a way to actually keep it up in orbit.
Well, it only works on small numbers. If the space station it's in low Earth orbit, so that it has a lot of drag on it. And every now and then they have to blast it back out. But for small station keeping, the gyros will take care of that. The big errors have to come out with a rocket. They have a booster. Russia has a booster they clamp on it. And we used to just hang the space shuttle on and fire up their engines.
Okay.
Okay, thank you very much.
Thank you, Eric. Okay, let's go to Mark next, sir.
Okay, I hope you can hear me. This question I was thinking, and you might have covered it already with Jeremiah, but is there any point at which you can spin the gyros fast enough and, you know, have the servos going fast enough that it can lift its own weight?
Nope.
Is that a mechanical problem or like an engineering problem, or is there it just simply won't work?
Well, it's physics. In order to get more thrust, you have to have a bigger gyro or a heavier gyro, so you're losing.
Oh, but it's not about the speed at which it spins?
Well, that contributes a little bit, but if you got a 300-pound gyro, say it's spinning at 10,000, it'll generate so much thrust, but then you have to have a frame, a motor, and a whole bunch of other stuff to make it go, and that just adds dead wood.
All right. So is it the servos that are creating the thrust, or is it the spin of the gyros?
There's 3 items: the spin, the speed of the spin, the mass of the rotor, and how fast you torque it. All 3 will contribute.
Oh, okay. So is there like an upper limit to what you can achieve percentage-wise in thrust?
I don't know about that. It's the main one is there's an upper limit on how fast you can spin the rotor before it blows up. You get much over 20,000 and it's going to come unglued.
Yeah, I get that. Also, is there any way to do this with Mercury? Similar effect.
have
In a,
no idea.
Okay, well let me jump back in really quick. Mark, let me put you on mute for just a moment. We have Tom Valone. Tom, do you want to show the video again from Kofi 12? I think we did this
You have
before.
a meeting. It seems imperative to show this video.
Yeah, no, go for it. Go for it. I would.
There we go. Sharing screen, and now push the play button. There we go. And this is only Model 2, but it's moving across a flat surface. You can probably hear the video, sound effects too. Yeah, and that's only the beginning. We have bigger and better ones planned for the future.
Tom, I'm sorry about that. I accidentally muted you. So could I ask, when you mentioned bigger and better ones planned, can you give us some links and addresses for people to learn more about this? Because I think you have this video online, right? And then you've got stuff planned. Can you tell us a little bit?
Actually, it's on futureenergy.org, www.futureenergy.org, and you'll see COPE 12, all the videos on YouTube. And Mike was in the first day, I believe, on Friday. So this whole talk, this presentation, and the video is all available for free from August. And COPE 12 is what we're talking about. And then we're looking at financing a bigger one with bigger gyros, bigger servos, and Mike can tell you all the details.
Okay. Well, thanks, Tom.
Well, we're planning for the supersonic transports with this is the power.
Yeah, but let me go back to Mike then. Mike, let me see. Let me ask you to unmute.
Okay.
Yeah, sorry, Mike.
Yeah.
Yeah, could you tell us more about some of the future projects then? Some of the stuff that Tom had mentioned?
Yeah, okay. What I've been working on as of yesterday was swapping out the servos. With the load from the gyros, the servos couldn't make specification. They were too slow. And so this fall we got some bigger servos, and then I got sick. So part of December and January, I couldn't do much. I'm just getting over the flu bug, which is, I was a little concerned about running out of talk because of the two pitches, whether I'd turn into a squeaker or a cougher. But anyway, I just got the two servos in there, and they're, I would say at least half more power coming out of them. And it's showing a lot more capabilities. So that's as of yesterday.
Okay, and then so I think Tom had mentioned futureenergy.org.
Yeah.
Do you have any more web resources or upcoming events that you could point us to?
Well, yeah, talk to Tom for that. What he's wanting me to do is build some bigger ones or design some bigger ones for him.
Okay, yeah, and then Tom's site too is the Integrity Research Institute, and
Yes.
Yeah, let me see, IRI. Tom, could I trouble you to just give us again just more web links, anything that you think would be relevant, I guess, to learn more about Mike's stuff, or
Well, it's more his stuff than mine.
Oh, sorry, Tom, you're still muted.
Yeah, thanks. It still is futureenergy.org. I don't have a great assistant that's doing fabulous website work. In fact, we got some offers for thousands of dollars and we can't afford it. But anyways, the important thing is that we're still working on a journal article that will give credence to exactly what Mike has discovered and proven. What is still in my mind is the foremost breakthrough that we had with COPE 11, and that was Mike came across with a prediction of 0.4 pounds of thrust, and then he measured, amidst all the noise, 0.4 pounds of thrust with this device, transducer. So this, to me, was a big breakthrough because theory and practice measurement were matching. And then we had COPE 12, where you saw this amazing video proving that he can actually produce sizable thrust in one direction. So Mike is defying the physicists who are already, I've got, you know, classic emails from professors and Hal Puthoff as the most important naysayer, the skeptic, all proving that conservation of conservation momentum prohibits this type of rectification of centrifugal force. And so this is great to defy the physicist and show it can be done, because
Good for getting hate mail.
and then you get hate mail too, right? Death threats and everything else. No, for sure. This is a journal article worthy of a sizable, you know, audience journal. I published in half a dozen overseas journals and nobody even notices, even though they're peer reviewed, they're, you know, from the other side of the world. But this is deserving of a serious mechanical engineering journal. And so once we get this published, I think we'll receive more media acknowledgement of Mike Gamble's greatness, and then we'll nominate him for a Nobel Prize and the recognition he deserves. I mean, this is definitely a breakthrough in science and breakthrough in physics. In other words, physics laws need to be rewritten to explain how this is even possible.
Yeah.
To, you know, come around with the equation. The force equations prove it works, but the physical laws prohibit it. I mean, go figure, you know, it doesn't make any sense. We're in this weird, I would say, interim between the old physics, even including quantum and relativity, and the new physics where we're going to get energy from the vacuum.
Well, Tom, thank you. And that was why, yeah, that was why I wanted to have you offer insights as well as playing the video, but I also wanted to give you the links and stuff so that people can follow up. I will put those in the description as well, so we'll get more people over there.
Yeah.
Okay, so let me see. Let me, so I'm going to mute Tom again, and then Eric Hermanson, sir, did you have a question? Eric? Okay, oops. Eric, I think you're muted. Oh, you know what? Eric just dropped off the conference. My apologies. Okay, let me see. Robert O'Keefe. Robert, sir?
Hi, yeah, I've got a, there we go, sorry.
Welcome back, sir.
I've got a question for Mike concerning the research he done on frequency. Some of the work that we were doing, there seems to be some similarities. We were doing research that we believe that there's subatomic particles that travel throughout the infinite of space, and different planets, different bodies have different gravitational effects based on the core of the planet. These frequencies travel through to the core. They travel through the atomic structure of everything, some of it being laminar flow, and some of it where these particles actually strike the electrons, and that interaction is the creation of photons, what we see. And the other interaction is the laminar flow creates almost like a magnetic pull, a gravity pull. So what we did in our labs at Tachyon was we set about looking at ways to try and shield the mass of different materials by creating several frequencies and creating harmonics in the atomic structure. And we did have some success with that, where we've built a number of machines. I believe one of them's on YouTube and on our website. I just wondered whether you might have thought that the correlation between what you've done from the planet outwards into space, whether you've looked at the possibility of these particles creating resonance coming back the other way towards the planet.
Well, I would say it works on any scale. It's just the smaller the size, the higher the frequency. So I am sure it would work on subatomic levels. That was my last comment, and the conclusions is the scale factor is determined by frequency. So atoms probably and subatomic particles would work very similar.
Yeah, it's just we had some results, some encouraging results with a similar research, but from the other direction, from particles coming from space that we believed existed. So we set about finding out ways to identify what was coming in and the way we believe that they interact with the massive objects and the way we pass through, like say lead or styrofoam. You can have two blocks of similar size or the same size with different masses, but we believe that the weight of the object was based on the amount of interactions that these particles create as they pass through that mass, and that determines like the gravitational effects on that object. So what we did, we set about to create harmonics in different materials and metamaterials we were working on to create a reduction in that flow through the objects, and we have had encouraging results doing that.
Yeah, so you're using resonance to generate a note is what you're doing.
Yeah, it's like a note, but it's based around well, we do a lot of work in magnetics, so we've found that you can't use an instrumental note, so you can't use like a normal harmonic scale. We're creating the harmonics through magnetic jets that we've created. So we focus several magnetic jets into a material and we resonate it that way. So the like several pure out of phase, or some are out of phase, some are in phase, but the combination of the harmonics, when you get it right, seems to create some sort of bubble around the object, and it does have an effect on the object's like mass. But that's as far as we've got.
Well, I would say you're working along the same direction.
Okay.
You're working at higher frequencies and smaller particles, but the principle of resonance is the same.
Mm-hmm.
Yeah, Robert, thank you again, sir. Let me go back to Yanis. Yanis, I think you had another question.
Yes, hi. So my question is, if a certain structure was made to resonate strongly at a certain height, would the natural rest height of the structure be at that resonance? So example, I have a UFO or a structure, let's call it, I have a structure engine, and this resonates at 11 hertz. So if the frequency is amped up high enough at these 11 hertz to resonate with the 11 hertz of that height of the 11 hertz, in my idea or whatever would be that the structure would then have a natural point of rest at that height. So if you have two of these engines in one ship, one maybe for 1 meter above the Earth and one for 5,000 meters above the Earth surface, then it could go up and down, and if you turn on both, you could actually modulate the speed. It would, for me, explain a bit the shape of the Tic Tac UFO, having two structures, one here,
Well,
and depending, yeah.
The first one is you've just put your finger on the angle that I'm working on the second one, where all this gravity is converted over to electromagnetics, and then it's just a matter of tuning the resonance for wherever you want to go.
Right, exactly, yes.
Now, as far as this Tic Tac thing, I think that's built right here in good old USA.
Yeah, I mean, it makes sense. Yeah, it's not so sophisticated. I mean, it is sophisticated, but not as much as some alien technology, I can imagine. Yeah.
The only problem is you're stuck between the surface of the Earth and the first harmonic, which is out at geosync orbit. If you go past that, you got no power. But you could use it for shuttling, transportation.
So it works below the surface of the ocean and above some certain height, but not beyond that, right?
Yeah, you have to have gravity involved. And once you get past geosync, you pretty much lost it.
I see. So mass is the problem. It's actually not that we have too few mass. So we don't have enough mass, actually. It's quite fun. Yeah. Okay. Thank you.
Okay. Thank you, Yanis. Okay. So let me see, we've got about 5 minutes left. Does anybody else have any questions that they want to sneak in? And again, Mike, thank you very much for being with us and for your patience with all these.
Well, you wanted me to sneak in that second pitch, so I tried.
Oh, no, this was amazing. I'm just waiting for, again, I'm waiting for more questions. Anyone? More questions? We have about 5 minutes left. Oh, there's Ron. Hold on. I'll get Ron. Oh, and I'll get, okay, Ron, you have to make it quick and then we'll do Hector after that.
I'm going to pass on some information very quickly. In terms of gyroscopes, the word molecular rotator solid will not get you many hits. But the way they teach camphor in high school and school, the rotation of camphor on water is intrinsic rotation. The camphor molecule, by having a dipole moment, they always taught that camphor rotates on water because of the break-in surface tension. And that's not it. Camphor itself has an intrinsic rotation for it, and you can make a gyroscope out of it. But that's enough. That's it.
I won't argue. I don't know much about it, but I'm sure you can make gyroscopes. Anything that spins is a gyroscope, including atoms or subatomic particles. They spin.
But the camphor molecule with its cyclage has the ability to outstrip a metal one with no bearings. It's just it's called rotation within a crystal. Bell Laboratories knew all about it in 1940. So,
yeah.
Okay.
Okay. Thanks, Ron.
That wouldn't surprise me. Like I said, I consider gyroscopes old technology.
Okay. And sorry about that. Let me go to Hector, who has been patiently waiting. Hector.
Hey, just got a general question. Since you guys were in the same place at Kent, did you ever run into a guy by the name of Jamie Childress over there?
Childress?
Yeah, Childress.
That name sounds familiar.
Yeah, it should. He makes a living out of that place. I think that's where the Phantom Works stuck him. Okay, no, I'm just curious if you ran into him because he would have probably been very interested in your work.
Well, there's a few people that like it, and there's a few people that don't like it.
Oh yeah, Jamie will look at anything. Trust me, that's what he does for Boeing.
Okay, well, thank you, Hector. Okay, let me go to Wayne next, and we're almost out of time. Wayne, go for it, sir. Wayne, I can't hear you. Looks like Wayne is having some problems. Okay. Well, we got about 2 minutes left. Does anybody else have anything they want to try and sneak in? And I should ask Jeremy. Jeremy, did you have any YouTube?
I don't have any questions on YouTube yet. If anyone's watching live, they can post their questions in all caps. I'll be able to answer them. I think, Tim, I'm going to shut down the stream because it's getting to 4.5 hours. I think it maxes out at about 5.5, and I'm going to need probably like more than an hour if I start now. So I want to
Okay.
have like a fresh stream going for my YouTube. So we can take a little break after whenever you're ready.
Good. Well, why don't we do that now? So Jeremy, let me mute you out. And before you shut it down, let's do an applause. So I am gonna, let me see, let me mute everyone back out. And yeah. So a big applause for Mike. Mike, thank you. 2 presentations and a Q&A, and that was remarkable and incredibly diverse and tons of information. So thank you. And thanks to Tom Valone as well. We will put links up to all of those websites so you guys can learn more.